All right, today we're going to dive deep into an incredible engineering marvel that's really shaking up global trade. We're talking about a whole new generation of gigantic container ships, and we're going to find out just how they're making our world a little bit greener.
So to really get a sense of just how huge this is, think about this. 90% of pretty much everything traded internationally, it travels by sea. Right now, there are something like 40,000 cargo ships out there on the oceans, and they're carrying, well, everything. The phone you're holding, the shirt on your back, even the coffee you had this morning. You could say our entire modern life is literally floating on these ships.
For the longest time, the name of the game in shipping was just get bigger. Bigger ships, more stuff. Simple. But now, a totally different question is pushing things forward. How do we keep moving all this cargo, but do it in a way that doesn't wreck the planet? The focus isn't just on size anymore. It's all about finding smart, sustainable ways to get the job done.
And the answer? Well, it's a total game changer. It was a massive $200 million bet to build not just one, but 9 of the world's biggest and, get this, cleanest container ships. And as if that wasn't enough, they had to pull it all off in just 2 years. Talk about pressure.
Okay, so let's dig in. What is the secret sauce here? I mean, what makes these new giants so revolutionary? Well, it really all comes down to one thing: what they're using for fuel.
This is where the real innovation kicks in. You see, for more than 100 years, ships have been burning this thick, sludgy, super polluting oil. But these new ships, they run on something else entirely: liquefied natural gas, or LNG for short. What they do is they take natural gas and cool it way, way down to a crazy negative 161 degrees Celsius. And when they do that, it turns into this really powerful, clean-burning liquid fuel. And the difference it makes is, well, it's just staggering. Just look at these numbers. By switching to LNG, sulfur dioxide emissions are basically gone. We're talking a 99% drop. Nasty air pollutants cut by 91%. And on top of all that, it even knocks carbon dioxide down by 20%. This isn't just a small step up, it's a gigantic leap forward. Okay, so a cleaner ship is great, but let's talk about the sheer scale of this thing. How on earth do you build something so massive? I mean, it's 400 meters long. That's like lining up 4 football fields one after the other. You obviously can't just build that all in one go.
The trick is to think in pieces. The shipyard itself is basically a small city with 6,000 people working there, and they use what's called a modular approach. They build the ship in these enormous sections, they call them blocks, and each one is already fitted out with pipes and wires and everything. Then they just bring them all together. It's kind of like assembling a giant, super high-tech Lego set.
And the whole process starts with some mind-blowing precision. Every single one of these ships is built from more than 12,000 separate steel sheets. To cut them, they use a laser that gets up to 18,000 degrees Celsius. I mean, just let that sink in for a second. That is 3 times hotter than the surface of the sun, and it just slices right through solid steel like it's nothing.
So how do you stick all these giant blocks together? Welders have to lay down an unbelievable 1,250 kilometers of welds for each ship. To put that in perspective, that's like welding a straight line from Karachi all the way to Lahore. And every single centimeter has to be absolutely perfect, because out in the middle of the ocean, even one tiny flaw could be a total disaster.
But, this giant steel hull, it's really just the shell. The part that's truly revolutionary, the real heart of this ship, that's hidden deep inside.
And right here is where we hit the single biggest engineering puzzle of the whole project. That LNG fuel, it has to stay at a bone-chilling minus 161 degrees Celsius. If it warms up even a tiny bit, poof, it turns back into a gas, expands like crazy, and, well, that would be a catastrophic failure. So the question is, how in the world do you keep a giant tank that cold on a moving ship that's sailing through all kinds of different weather? So, what was the solution? Basically, they built the world's biggest thermos. And I'm not kidding. This thing isn't just a fuel tank. It's an engineering masterpiece that took 9 months to build. It's designed to hold 20 million liters of that super cold LNG. We're talking enough fuel to fill 6 entire Olympic-sized swimming pools. And the real secret to this giant thermos is actually in a layer of steel that's surprisingly thin, only 1.2 millimeters thick. But look at this cool wavy pattern it has. That's the key. It lets the metal act kind of like an accordion, so it can shrink and expand with those crazy temperature changes without cracking under all that pressure.
And just to give you an idea of how advanced this technology is, the very same design principle is used on the International Space Station to protect it from the insane temperatures in space. Yeah, this is quite literally space-age tech.
just sailing around on our oceans.
Okay, so with that incredible fuel tank in place, it was time to give this steel giant some serious muscle. The next big job was fitting the massive engine and getting this beast ready to finally hit the water.
And the engine, well, it's an absolute beast. This ship is powered by the largest natural gas engine on the planet. It's 6 stories tall, weighs over 2,000 tons, and it cranks out a staggering 85,000 horsepower just to turn that giant propeller.
Now, connecting that monster engine to a 92-ton propeller, that takes insane precision. And to get it right, the engineers use a trick that's surprisingly old school. They literally just paint the shaft with some blue dye, slide it into the propeller, and then pull it back out. The pattern the dye leaves behind shows them exactly how well the two pieces fit together, so they can make tiny adjustments, right down to the millimeter. Kind of brilliant, right?
And when you look at the final details, the scale is just mind-boggling. They use 1 million liters of paint just for the hull. A single link of the anchor chain weighs 300 kilograms. It can carry more than 23,000 shipping containers in one go, and up on the bridge, the captain uses a smart eyes system that gives him a full 360-degree digital view of everything around the ship.
But even then, the job wasn't done. Before it could take on a single paying container, the very first ship, the Jacques Saudet, had to pass its final exam. We're talking 15 grueling days of sea trials. They pushed every single system to its absolute limit. Full power engine tests, slamming on the emergency brakes, checking all the navigation, everything. It was all to prove that those 2 years of hard work really had built a ship that could handle anything the ocean threw at.
And then, finally, after 2 years of non-stop work and some seriously groundbreaking engineering, the mission was complete.
You know, when you really look at it, this whole story is about so much more than just steel and engines. It's really a testament to the amazing ingenuity and just plain hard work of thousands of people. The engineers, the welders, the designers, all of them, coming together to build something everyone thought was impossible.
And they did it. Against all odds, the shipyard hit that crazy deadline. All 9 of these revolutionary ships were delivered on time, and that's in a really powerful message, It proved that even the biggest, most traditional industries can actually change course and head for a cleaner, more sustainable future.
So right now, those 9 ships are out there, sailing the world's oceans. They're proof that with enough bright ideas and hard work, we can make these literal mountains of steel sail cleanly across the water. And it really makes you wonder, right? If we can solve a problem this big, what's the next monumental challenge we're going to tackle?